Alright folks, hello and welcome to this video lesson on section 5.5, dividing polynomials. Let's get right to it. We're going to talk a little bit about polynomial long division, but first I want to get some division terminology out of the way, as well as the division algorithm. So division terminology, let's just take a very simple example. Say you were doing something like 15 divided by 4. You might remember to set that up as a long division problem. You would put 15 under the long division symbol, and then you would put the 4 on the outside. Now, just so you know, each of these terms, or each of these items in our division problem has a name. The dividend is the expression being divided. So that would be the 15 in our example. That's the dividend. I'll point to it with a black arrow. The divisor is the thing you're dividing by, or in this case, the 4. I'll point to that with a blue arrow. Now, as you carry out the division, you will discover a quotient and sometimes a remainder. So I go 4 into 15, it goes in 3 times. 3 times 4 is 12. Subtract, we have 3, and 4 does not go into 3. So we would say that 3 is the quotient, and I will point to that with a red. Notice the quotient is the expression resulting from the division, but not including the remainder. So this 3 would be considered the quotient, and then the remainder is also 3. So for that, let's try green. The remainder would be this 3 down here. So we would say our final answer to this division problem is 3, and 3, which is the remainder, over 4. The divisor. You do the remainder over the divisor, 3 3/4 would be our answer. So this terminology, we're going to use the same type of terminology when we look at dividing polynomials. Obviously, long division you saw when you were, in 3rd or 4th grade, and here we're going to get a little bit more sophisticated than that. So here's the division algorithm as it's written for polynomials, or commonly written. Each of these items, f of x, d of x, g of x, etc., those are not really standing for functions. Those are just different ways of writing polynomials. They could be functions, but here I just want them to be a polynomial. So f of x is a polynomial, d of x is a polynomial, and when you do f of x, which is the dividend, as we should remember from the previous slide, over d of x, which is our divisor. Okay, so you have a polynomial and you're dividing by some divisor. Then you get, always, a quotient, which is our q of x. Okay, the result, not including the remainder, plus some remainder, r of x, which is our polynomial for the remainder, and then we do always put the remainder over the divisor when we're writing our final answer. And just take note of this statement here: the degree of the remainder must be less than the degree of the divisor. Otherwise, you keep the division going. So for the algorithm is just a fancy word for a step-by-step process or procedure. You're going to keep going. You say this goes into this how many times, and then you multiply, and then you find a new term, and then you keep going with your long division until this polynomial, r, has to have a degree that's less than the divisor. Once that occurs, that's when you know how to stop. Okay, if you go back to, you'll see that the remainder is less than the divisor. Well, with polynomials, the remainder has to have less of a degree than the divisor. So similar concept, just a few different terms. Now let's look at some examples. Okay, so for this example, we're going to divide 2x to the 4th plus x cubed plus x minus 1 by this divisor, x squared plus 2x minus 1. So the first thing I'm going to do is set up a nice large long division problem. Give ourselves plenty of room, and I'm going to put the divisor on the outside and the dividend on the inside, just like we did with numbers. Don't be afraid that these are algebraic expressions. I'm going to walk you through the steps of how to handle them. Our dividend needs to go in here. And notice that it's written in standard form. The exponents are decreasing. 2x to the 4th plus x to the 3rd. And then we have plus x and minus 1. Notice I left a gap because there's no x squared term in our polynomial. Well, when you're doing the long division, you don't want any gaps to take place. So we're going to add what's called a placeholder, and we're going to have 0x squared. This is perfectly legal because 0 times a number is just 0, so it's not affecting the value. But by having that placeholder, it allows the division to line up and work out nicely. Now let's proceed with our division. First thing you want to do is just consider the leading terms. The first term in each polynomial, the divisor, come on, Mr. Drosa, the divisor, x squared, and the dividend. So all you have to check is the first term to see how many times, quote unquote, it goes in to the other polynomial. So I want to say, how many times does x squared go into 2x to the fourth? That's kind of the question we asked with long division. Here we're asking, well, if I did x squared times what? That'll give me 2x to the fourth. And whatever that what is going to be your first term in your polynomial long division. So if I do 2x squared up here, well, think about it. If I did x squared times 2x squared, I'd get back to 2x to the fourth. So that's how I figure out my first leading term. You do the leading term here times what would give you the leading term of the dividend. And whatever that what is goes as your first term in your quotient. Now, just think back to long division. After you have the first term, you multiply. So we have to do 2x squared times the entire divisor. That's going to require the distributive property. I'll do 2x squared times x squared, then times 2x, then times minus 1. And for each of those results, you want to line it up under the term of the polynomial that has the same degree. So try that, and then see if you agree with what I get. So there are my results, and double check your multiplication to make sure you agree. Now, you might remember what we do in long division next is we subtract. You must remember to subtract. It is very crucial, and it is often forgotten, and this is where 90% of the mistakes occur. That's not an exact number, but this is where really most of the mistakes occur when people are doing polynomial long division. They mess up the signs or forget that they are subtracting. So just picture you have a little man over here. He has 3 hairs. You can call him whatever you want. We will call him Phil, and he is yelling, subtract, when you do long division. Subtract. Okay, you need to remember that. So let's subtract across the board. We're going to do 2x to the fourth minus 2x to the fourth. Those just add to 0. So they cancel out. That's pretty nice. Next we have x to the third minus 4x to the third, which gives us negative 3x to the third. And lastly, we have 0x squared minus negative 2x, which gives us plus 2x. Oh, I'm sorry. This should be a 2x squared. Almost a board point for whoever you were thinking that. I apologize about that. Okay. Next up, we will bring down our next term and just repeat the process. So we have a plus x. And we will now see the leading term. X squared goes into negative 3x cubed. How many times? Or x squared times what gives me negative 3x cubed, and that will be negative 3x. Perform the multiplication, negative 3x times this entire divisor, and then write the terms under their proper degree, or the degree of the term that they match. So negative 3x times x squared is negative 3x cubed as desired. Those should always match up. They're always going to cancel out those first terms. Then we have minus 6x, and then we have plus 3x. You must go very slowly and carefully to get these correct. Okay, now it's time to subtract. Negative 3x cubed minus negative, don't forget, Phil is yelling out, subtract, subtract. And when you subtract those terms, they will add to 0. Here we have 2x minus negative 6x, which is positive 8x. Then we have x minus 3x, which gives us negative 2x. I keep doing this, darn. This is squared, and this is squared. I apologize for those mistakes. You can see how easy it is to make little mistakes like that, but don't make them. I was so focused on Phil that I did not take into account the degree. But take note of that there. So this is a square. Then we will bring down the final term, minus 1, and complete the procedure. X squared times what gives us 8x squared? Well, that will be plus 8. That will give us 8x squared, and then plus 16x, and then minus 8. Be very careful. Final subtraction, these add to 0. Negative 2 minus 16x, I'm just going to write it over here, is negative 18x. And then negative 1 minus negative 8 is plus 7. There's the x. So that will be our remainder, and we know we're done, and we can stop because this has a lower degree than our original divisor. So now we are in position to write our final answer. And our answer to this division problem is the polynomial 2x squared minus 3x plus 8, that's the quotient, and then we have plus the remainder over the divisor. Here the remainder is negative 18x plus 7 over the divisor, which was x squared plus 2x minus 1. And this big fancy expression is the result of our division. As you can see, a lot of steps, and you must be very careful. We are going to do one more example, but I'm going to ask you to try it on your own first, and then see if you agree with my answer. Here is the example. Why don't you pause the video and see if you can set it up correctly, and then start doing the long division. This would be the correct setup. Notice you have a 0 placeholder here, where we have the plus 0x, so that each degree is represented, and each term is covered. Next, perform the division, and see if you can get to the answer. I suggest pausing the video, and then I'm going to show the first step of my work. Here is what I have. And notice I brought down 2 terms because the 0x, there's really not much there. It's just a 0 term. So you're allowed to bring down as many terms as needed as you go along. Sometimes you'll have to bring down 1. Sometimes you'll have to bring down 2. Just whatever makes the division work for you. Now I'm ready to perform the second step. And we have our x times what gives us negative 10x squared. And that will be minus 10x. Perform the multiplication. We have minus 10x squared. And then we have minus 20x. Perform the subtraction. See how bringing down the minus 28 doesn't change anything, because we're going to bring it down regardless. If you subtract 0 from it, it's still there. These add to 0. And we have positive 20x here and minus 28. Lastly, x goes into 20. That'll be, or 20x, that'll be plus 20. And will give us 20x plus 40. Subtract these, and we have minus 68 is our remainder. Let's write our final answer. I'll make some space. The polynomial result will be 3x squared minus 10x plus 20, and then our remainder minus, or we'll do plus, and then minus 68 over, sorry, that's a bad 8, the divisor, which was x plus 2. And that is how you divide polynomials with long division. I suggest maybe rewatching both of the examples. Listen carefully to what I'm saying. I know I made a few boo-boos when I wrote on the screen, but I was saying the terms accurately as I was dividing them. And go back and see if you can follow along with the step-by-step process. Finishing up, let's just summarize what we did. First, we talked about the terms of division: dividend, divisor, quotient, and remainder. Second, we talked about the division algorithm and how long division with polynomials is similar to long division with numbers, but now we just have polynomials in the expressions, as our expressions. And then third, we looked at some long division examples and a step-by-step process. That's the toughest part. It's going to take a little getting used to, but practice will make perfect. Also, as a final note, don't forget about placeholders when you have missing degree terms. You need to make sure they're all accounted for in the dividend, and if you don't do that, you're going to get a messy, messy long division problem. That is section 5.5, and I thank you for watching this video lesson.